All right, so here we are ready to balance one of our redox reactions. This is a redox reaction that takes place in an acidic solution. Now, remember, as we go through these rules, I'm going to try to label these as I go and do this in as stepwise and clear of a manner as I can. And so hopefully you can come back and use this as a resource as you balance other redox reactions as well. So the first thing that we always do when we have one of these redox reactions is we have to identify what's being oxidized and what's being reduced. And we do so by figuring out the oxidation numbers of all the elements in the chemical equation. Now, if you have a printout of your rules for assigning oxidation numbers, that would be handy to have right here. And so you might want to pause the video and grab that so you can go through these rules for assigning oxidation numbers as I go through them. I will be going through them relatively quickly because this process does take a little bit of time. And so you may want to slow this down a little bit and make sure you can figure out all the rules as you go. So I'm going to start just on the left-hand side with the rules that I know, and I'm going to figure out the oxidation number of the elements that I may be unsure about. For example, hydrogen has an oxidation number of +1. Okay, so that's +1. I have 2 of them. That gives the hydrogens a total oxidation number, sum of the oxidation numbers of +2, which means my sulfur here must be -2. Okay, so we've got, I'll try to make this clear here, +1, there we go. All right. So we've got now hydrogen is +1 on the very far left, sulfur is -2. Now we go to the next compound. I know the oxygen rule comes first, so each oxygen is a -2 oxidation number. I have a total of, and I'm going to circle that, and so I know the oxidation number of each oxygen. I'm going to multiply that by the 3 oxygens for a total number, or total charge from the oxygens of -6. Now, whatever the oxidation number of nitrogen is plus the -6 has to equal that charge on the polyatomic ion. So a +5 plus a -6 will equal -1. Okay, so that gives me the +5 for the nitrogen there. Now, if I go to the next product on here, the first of the products actually, I have oxygen is -2. I only have one of them, which means my nitrogen must be +2. And then my sulfur is an element, so sulfur is going to have a 0 formal charge. Now the next thing that I want to do is identify what elements have changed oxidation number. Well, sulfur has gone from a -2 to a 0. And so I'm going to use my tie lines to attach those together. Now if it goes from a -2 to 0, that means it's lost electrons, so I'm going to write in Leo here. Okay. Then I'm going to look for others. Oxygens are -2 on each side. Hydrogen, well, I only have one hydrogen here. That'll come into play later, so that's okay. But I do have my nitrogen, which I should notice is a +5 on one side and +2 on the other. So if it's gone from a +5 to a +2, it must have been reduced. So we're going to write in here, Gur. So the nitrogen has been reduced. And so this whole thing that we've done here is really that step 1 of the rules for balancing redox reactions. Step 2, I'm actually going to write step 2 on both sides. We're going to do the balancing of the oxidation half reaction on this slide, and on the next slide we'll do the reduction half reaction. So we'll do oxidation half reaction. So the oxidation half reaction, I'm going to whatever's attached to the tie lines that have Leo associated with them. And so that's the H2S reacting to form sulfur solid. Now I don't need to keep my phases in here. In fact, if you don't want to write the phases while you're balancing it, that's fine. But at the very, very end, when you have the totally balanced chemical equation, you need to make sure those phases are in there. So for now, I'm going to leave the phases out. And then we'll add them in at the very end. So there's our start to our half reaction. Step 3, and we'll do the reduction half reaction in a minute. Step 3 is the balancing other elements. Right, so it's other elements than hydrogen and oxygen. Okay, here it's already balanced. So I'm just going to say, well, now I've just got H2S reacts to form sulfur. I don't have to balance anything. I've got one sulfur on each side. I'm just going to leave it at that. Then I'll go on to step 4. Step 4 is to balance oxygen. Now we do that by adding an oxygen to either side, but you know what? It's also already balanced. So that means that for step 4, I get to a half reaction that looks like this. H2S reacts to form S. Step 5, well, remember we're splitting step 5, which is balancing hydrogen, into 2 parts. So 5A. Step 5A said we're going to add hydrogen ion to the side that needs more hydrogen. So here on the left side, I have 2 hydrogens. On the right side, I have 0. So we'll rewrite our equation, this time including the number of hydrogen ions we need to balance out the hydrogen. So H2S reacts to form S, or sulfur, plus, well, I need to get 2 more hydrogen ions. So I'm going to put a 2H plus on the product side. Okay. 5B is the step that gets us to having either hydronium or water, depending upon if it's acidic or basic. Here, we're going to get to hydronium. Notice I have 2 hydrogens here, 2 H pluses, 2 hydrogen ions. So what I need to add is water to each side. Okay, and so I'll do that here. I'll say, okay, well, I need 2 water, so I'm gonna have 2 H2O plus H2S react to form sulfur plus 2H plus 2 H2O. Except when I have H plus and H2O together, those combine to give us 2 H3O plus, right? And so now I can sort of finish up 5 by saying, well, I've got 2 H2O plus H2S react to form sulfur plus 2 H3O plus. And so the only thing I don't have balanced here is my total charge, and that's going to be step 6. So in step 6, I'm going to look at the charges. Well, each water is neutral, so 0 charge. Each dihydrogen sulfide, neutral, so that's 0 charge. So I have a total of no charge on my left side. On the right side, sulfur solid has a 0 charge, and then the hydronium ion, I have 2 hydronium ions times, well, each of them is plus 1, so that gives us a total of plus 2 charge. Okay, so there's a difference here. So we've got a plus 2 charge and we've got no charge, or 0. And so that means I need 2 electrons. Those 2 electrons are going to go onto the more positive side. So our overall reaction should be 2H2O plus H2S reacts to form sulfur plus 2 hydronium ions plus 2 electrons. And so now we should have a balanced half reaction. Okay, and we'll go on and do the reduction half reaction in our next slide. So our reduction half reaction will be we'll start with the NO3 minus reacting with, or to form NO. Okay, and so again, that's step 2. Again, now we follow all of these same steps as we balance this half reaction as well. So the first part after splitting them up is to balance other elements. And we have already balanced. Okay, so it's still NO3 minus reacting to form NO. Step 4 is to balance oxygen. So to balance oxygen, I have 3 oxygens on the reactant side. I only have 1 on the product side, which means I need to add 2 more oxygens. And I do that by adding 1 water molecule for each oxygen. So here, what I do is I put NO3 minus reacts to form NO plus. I need 2 oxygens, so I put 2 waters. Now in the next step, we're not going to worry about touching these waters. Leave those waters alone as part of the overall reaction where the oxygen is now balanced. If you do anything besides what the steps that I explained here, you may pull your reaction out of balance in terms of the oxygen. So let's do step 5, which is balancing hydrogen. Okay, so 5A says that we have to add hydrogen ions to the side that needs more hydrogen. So in this step, well, on the left-hand side, there are 0 hydrogens. On the right-hand side, well, I've got 2 times 2 is 4 hydrogens, which means I need to add 4H plus to the left-hand side. And then I can write the rest of the equation out. So I should actually have a balanced equation here, but I need to get my hydrogen or the hydrogen ion into a physically meaningful state, which is hydronium. And so in 5B, what we're going to do is we're going to add plus 4 H2O to each side. So on the left side, when I rewrite this, remember these combine to give us hydronium ion. So 4 H3O plus NO3 minus, react to form, well, I've got NO. Now I added 4 waters to the original 2, so I need to make sure I have now 6 waters on the right-hand side, on the product side. And then in step 6, I need to figure out what is the total charge on each side. So I've got from the hydronium ion, 4 times the +1 charge gives me +4. From the nitrate, I have 1 times the -1 charge, which gives me -1. So this is a total of, well, +4 and -1 is +3. On the product side, I've got 0 and I've got 0, which gives me 0, which means I have a difference of 3 electrons, and they go to the more positive side. So for our balanced overall half reaction, I should have 3 electrons plus 4 hydronium ions plus nitrate, react to form nitrogen monoxide plus 6 waters. And if you want to, you can always check to make sure this is balanced here too. And so I can do that by saying 4 times 3 is 12 hydrogen atoms on the reactant side. 6 times 2 is 12 hydrogens on the product side. For oxygen, I've got 4 times 1, which is 4, plus another 3 gives me 7. On the reactant side, on the product side, I've got 6 times 1 from water, plus another 1 is 7, and then I've got 1 nitrogen on each side. And so my whole reaction should be balanced at this stage. But what I want to draw your attention to now is the number of electrons. Notice here, 3 electrons in this half reaction, on the reduction half reaction as a reactant. And if I go back up to the other one, I've got 2 electrons. And so this is where I'm going to take these 2 equations, but I'm going to multiply them by a coefficient that'll get me to the lowest common multiple. Well, the lowest common multiple of 3 and 2 is 6. So I'm going to multiply this equation entirely by 3. And I'm going to multiply this equation by 2. Right? So times 3 for the first one, and times 2 for the second one as we put this together in our next slide. Okay, and so for step 7, we're going to take our oxidation half reaction. Okay, and so the oxidation half reaction, again, this is going to be when I multiply these, right? So I'm going to go back up to my oxidation. So I've got 2 H2O plus H2S. Well, that should be 6 waters and 2 dihydrogen sulfides. Okay. And here's where I'm actually going to start to put my phases in here. So H2S is a gas. Then I'm going to go right on back up. Oh, shoot. Excuse me, I should have 3 of these. I can do math. 3 times 1 is 3. And then I'll go back up and look at my equation, right? I'm multiplying these by 3, so I've got 6 waters, 3 H2S's. I should have 3 of the sulfur solids, 6 of the hydronium ions, and 6 electrons. Okay. Now that should all balance out if I did it right. So 6 times 2 is 12 hydrogens plus another 6. That gives me 18 hydrogens. On the other side, I've got 6 times 3 is 18. Oxygens, 6 times 1 is 6. And then 6 times 1 is 6, and then 3 sulfur. So that looks like I did the right multiplication. So it's always good to check in this stage 2, just to be sure that you remember to multiply all of those coefficients by the right value. This is sort of where one of those most common mistakes comes in for most people. Then we'll take our reduction half reaction. Okay, and this is, again, remember, we've already multiplied the first one by the value to get to the lowest common multiple. We're going to do the same thing here. So now I've got 3 electrons there. I'm going to multiply each of these stoichiometric coefficients times 2. So I should have 6 electrons, 8 hydroniums, and 2 nitrates. Oop, that should be 8 H3O plus 2 NO3 minus. And then if we're multiplying them all by 2, I should have 2 nitrogen monoxides and 12 waters. Okay, looks pretty good. Water should be a liquid in here. Okay, next thing, I put them together. Now I'll try to color code this a little bit to make sure it's clearer. So I'll start with blue, and I've got 6 electrons on the reactant side of the second equation, 6 on the product side. So those are going to cancel each other out when I add them together. So I'm just going to get rid of those now. Then I'll go to green. I'm going to look at my waters. Well, here I have 6 waters on the reactant side, and I've got 12 waters on the product side. So what I'm going to do is I'm going to get rid of all 6 of those waters. I'm going to subtract 6 waters from each side. So that's going to go away, and that's going to change to 6. Okay. Then I can go ahead and look at, we'll do purple for this one, my hydronium. So my hydronium, I've got 6 H3O plus and 8 H3O plus, and so I'll subtract 6 from each side. Those will go away. That will change to a 2, right? Subtracting 6 from 8 gives us 2. And then I can put these all back together. So now let's take what we have. So in my reactant side from the first reaction, 3 H2S gas remain, plus 2 from the second equation, the half reaction for the reduction. I've got 2 hydronium that remain, H3O plus, aqueous, plus I've got 2 nitrates that remain. Okay, that takes care of all of my reactants. Now I've got 3 sulfurs. Try that again. Make it legible. Here we go. Sulfur, solid, plus. Looks like that takes care of all of the reactants in my first, or the products in the first equation. So plus 2 NO gas, plus 6 H2O liquid, and that takes care of everything. And so I've gotten rid of all of my superfluous elements, ions, compounds, and so now I can add these up. So that was step 8, was recombining those half reactions. Step 9, well, we're going to tally it up. We've got sulfur, we've got nitrogen, we've got oxygen, and we've got hydrogen on each side. So let's count the sulfurs. I've got 3 times 1, gives me 3 there. I've got 3 times 1, gives me 3 there. Let's go to the nitrogens. I've got 2 times 1 gives me 2 here. Over here, 2 times 1 gives me 2 there. So good. Yep, so far so good. Next, oxygen. Well, I've got 2 times 1 plus another 2 times 3. So that gives me 8 oxygens. Now I have 2 times 1 plus 6 times 1. That's also 8. So that oxygen looks good too. For hydrogen, I have 3 times 2 plus 2 times 3. That gives me 12. And over on the product side, it looks like I have 6 times 2 gives me 12 as well. So we're good, which says that our reaction here should be the correct reaction for this balanced chemical equation. And that's how we balance a redox reaction in an aqueous solution. There is one more thing to look for, is look for all the stoichiometric coefficients. Remember, anytime you balance a chemical reaction, you need to make sure that if you can reduce them, that you do. But here, we've got 3's and 2's. Those are all prime numbers. And so if you have 3's and 2's, you cannot reduce them any further. So that's balancing in an acidic solution. In our next video, we'll balance in a basic solution.